In the last 300 years, humanity has developed remarkable ways to harness energy, transforming our world. Beyond visible structures, there exists an invisible order called information, harnessed by nature for billions of years. The film narrates the story of information, its fundamental role in the universe, and the immense power unleashed by manipulating it. It explores the transformative impact of symbol, writing, codes, and computer on our understanding of the universe, revealing how information can create order in cosmos collapsing into disorder. Information, to seemingly straightforward, has been a challenging concept for science. Over 5,000 years ago, the Mesopotamians invented writing, the most transformative technology, allowing ideas to endure through time. Writing on clay tablets became a powerful means to express information outside the human brain, enduring for thousands of years. The film highlights a tablet buried in 2100 BC as a message for the future, showcasing the enduring nature of transformation stored on clay. The Mesopotamian scribes discovered that information could easily transform from spoken sounds to symbols on clay tablets, marking the beginning of humanity's understanding of the power of symbol. Writing remained the primary information technology for 4,000 years until the 19th century Industrial Revolution. In Lyon, French, during the 18th century, the silk weaving industry thrived, and Joseph Marie Jacquard developed a revolutionary loom in 1804. The Jacquard loom could be programmed using punch cards to weave intricate patterns, revealing a fundamental truth about information. It could be translated from picture to punch card to the finished fabric. This development marked the beginning of a new breed of information technology that hints at the immense power of information. The film emphasized the importance of information in various technologies emerging from practical origin in the 19th century, showcasing the depth and power of the concept. The story underscores how information can be translated into abstract symbol, creating a profound impact on communication and technology, ultimately shaping the course of human history. Jacquard's loom revolutionized the silk industry by revealing the power of structuring information. It demonstrates that the essence of something could be captured, vital information extracted and represented in other form using just two symbols, a whole or a blank space. The portrait of Jacquard woven in silk with hundreds of thousands of stitches exemplifies the idea that simple system, like punch card, can capture the essence of the complex object. The text then explores the historical context of information transmission, highlighting the limitation of the traditional method relying on the speed of cycle object. The 19th century brought a dramatic increase in the speed of information transmission with the discovery of electricity as a potential medium. Various early electronic communication devices using electricity were developed, each with complex codes. However, Samuel Morse and Alfred Vail revolutionized communication in the 1840 with an incredibly simple and effective code. It called Morse code. This development marked a significant shift in the way signals were sent and endured, becoming a timeless method still in use today.
So I will continue to talk about the video. So there are several points in the video. The first one, development of information manipulation methods. In the beginning, information was manipulated and transmitted in physical forms such as image, sounds, or text. Images were manipulated by drawing, engraving, or printing, and sounds manipulated by being sounds, spoken, or recorded. and the text is manipulated by written type or printed. So in the 18th century, punch card began to be used to manipulate information, and punch cards are considered to have small holes that represent certain information that were used to control textile machines, weaving machines, and other machines. In the 19th century, telegraphs began their use to transmit information over a long distance. Telegraphs use electrical signals to transmit text messages that allowed information to be transmitted quickly and efficiently, thus paving the way for global communication. So the next point is Maxwell diamond. Maxwell diamond is experimental thought proposed by James Clerk Maxwell in the 1867. Maxwell demands a small creature that can see and control the movement of gas molecules, and it can separate gas molecules based on their speed. Maxwell's demand seems to violate the cycle law of thermodynamics, which states that the entropy or disorder of a closed system always increases. If Maxwell demands could separate the gas molecules based on the velocity, then he could create a temperature difference between the two parts of the closed system. And then Maxwell demands is a very interesting experimental thought, but it is also very difficult to prove experimentally. To date, there is no definitive proof whether Maxwell diamond can actually exist. And then the next one is Turing's universal machines. And Alan Turing was a mathematician and computer scientist born in England in 1912. Turing was one of the most important figures in the development of computers. In 1936, Turing published a paper entitled "A Computable Numbers with Application to the Arithmetic Problems." In this paper, Turing introduced the concept of these Turing machines, which is an abstract model of a computer. A Turing machine is a machine that operates by following set of rules that can be programmed to perform variety of tasks, including mathematical calculations, data processing, and simulation. The concept of the Turing machine became the basis of the development of modern digital computers. And then, portrait of the future, information technology. Information technology continues to develop rapidly. In the future, we can expect computers to become increasingly sophisticated and versatile. They will be able to perform many tasks that are still done by humans today, such as driving cars, caring the sick, and educating children. Computers will also increasingly play a role in understanding and modeling the real world. Computers can be used for weather simulation, medical research, and product design. With the development of information technology, we will live in a more connected and informed world. We will have greater access to knowledge and information, and we will be able to communicate with people from all over the world more easily. Okay, everyone, I'm Saskia Maharani Putri. I give it back to the next presenter.
Hello everyone, I'm Siska Saputri. I will continue to talk about the information in the video, and the video talk about the ideas of Alan Turing and Claude Shannon regarding information processing and communication. It highlights Shannon's influential paper on the mathematical theory of communication, which laid the foundation for modern communication networks and introduced the concept of the bit. And the video emphasized that information is not just an abstract concept, but is closely tied to the physical world and follows the laws of physics. Yes, it also emphasized that importance of manipulating and storing information in various physical systems in the modern information age, as well as the inherent cost associated with ordering information. And in that video, the speaker also talked about how did Claude Shannon's paper on the mathematical theory of communication contribute to the development of the modern communication networks. And Claude Shannon's theory, a mathematical theory of communication, laid the foundational groundwork for the development of modern communication networks by providing a quantifiable measure of information and a framework for understanding the process communication in a rigorous, in a mathematical way. And Shannon's insight was to recognize that the quantity of the information in a message is not related to its meaning, but rather to its unexpectedness, or how unusual the message is. And he proposed that information is related to the degree of surprise in a message, with more unexpected messages containing more information. And furthermore, Shannon introduced the concept of the bit as the fundamental unit of information, which is a contraction of binary digit. He showed that any message could be translated into a sequence of binary digits like ones and zeros, and making information manageable, controllable, and precise. And this binary representation of information become the common language from all forms of data, or whether it be sounds, pictures, or text, and could be transmitted by any system capable of being in just two states. And Shannon's work provided the theoretical underpinnings for the digital revolution, enabling the encoding and transmission of information in a digital format across various types of communication networks. Ladies and gentlemen, his theory addressed the challenges faced by the Bell telephone network and other communication systems in measuring and quantifying information, which was essential for efficient and reliable exchange of the data over long distances. By transforming the abstract concept of information into something tangible and measurable, for example, Shannon's theory became the cornerstones of information theory and has had far-reaching implications for the development of the internet and digital telecommunication and the broader field of the data science, I think. And in that video also talk about in what ways is information inseparable from the physical world and governed by the laws of physics. Yes, in that video, information is inseparable from the physical world because it must always be embodied in the physical system. Whether it is encoded onto a stone, for example, a book, a CD, or any other medium, this embodiment gives information its unique properties and ensures that it adheres to the laws of physics. For instance, the act of organizing information, much like creating physical order, has an inherent cost that requires energy expenditure. Moreover, the concept of Maxwell's demon illustrates the deep connection between information and physical reality. The tough experiments showed that while the demon could seemingly use information to create order without expending effort, for example, in reality, the erasure of information, which is a necessary part of the demon's process, requires energy. For example, this establishes that information processing is a subject to the second law of thermodynamics, just like any other physical process. And the discovery of the latter limit further cements the relationship between information and the physical world by quantifying the minimum amount of energy required to delete one bit of information. This limit is a fundamental part of the fabric of the universe, demonstrating that information, no matter how abstract it may seem, is governed by the same physical laws as everything else. And in conclusion, the pioneering work of Claude Shannon, alongside the contribution of Alan Turing, has been instrumental in shaping the modern information age. At the Shannon's a mathematical theory of communication not only introduced the fundamental concept of bit, but also firmly established the intrinsic link between information and the physical world, I think. And his insight into a quantification, manipulation, and storage of information have become the bedrock upon which modern communication networks are built, and underscoring the profound impact of his theories on the evolution of technology and the way we process and communicate information today. I think it's from the theories of Shannon or the Alan Turing. So I think that's all for the information from that video. I think that video is a very useful to our to make us know about the internet or the theory of the mathematical theory and communication. So I think that's all for this video. Thank you very much for your attention.